Richard Dawkins was once approached in one of his conferences and asked, "Should I study the philosophy of science?" And in response to this, he said, "No, just do the science." Find out why he would say this in such an aggressive way. Assalamu alaikum, brothers and sisters. In this episode, we're going to look at the philosophy of science. And in particular, we're going to look at one of the major problems within the philosophy of science. That's the problem of induction. Now, I know these sound like big terms, but we're going to break them down so it's very easy to digest. So firstly, what is induction? Induction is basically a method that science uses. It heavily relies upon this. And when you use induction, what you do basically is you go from a limited set of data collected by the scientist, and based on this data, you make a conclusion, a general conclusion which tries to sum up for the whole. Now, let me give you a few analogies to put things into perspective, and then we'll discuss why this is a problem. So, imagine you're a scientist and you've been commissioned to go and study the monkeys in the Amazonian rainforest, right? So you pack your bags, you get all your notebooks and your pens and all of the equipment you need, you catch your flight, you go into the heart of the rainforest. And you sit there within your little tree house that you've been given or assigned to stay in for the next month or two. Now, in the next 2 months, you look out of your window every single morning and you look at the trees and you observe the monkeys that jump from tree to tree. For in those 2 months, let's say you've observed 20,000 monkeys, okay? And you've taken detailed notes of every single monkey that you've seen. And these 20,000 monkeys, every single one of them was white in color. He had white fur, okay? Now, based on this data, you collect your data, you pack your bags, you come back to the UK, and you report back to your main head scientist. So, based on your data, as a scientist, what you would do is this. You would take your limited data, which is the 20,000 monkeys you've observed, and you make a general conclusion based on this data. So what you would say is that all monkeys that you've observed in the Amazonian rainforest, all monkeys in the Amazonian rainforest are white or have white fur, okay? This is something science always does. It's impossible. You can't have the totality of data. It's not feasible. You can't observe every single monkey that exists in the Amazonian rainforest. You're always going to have this data collection, this set of data. And based on this set of data, you will make a general conclusion for the entire set of monkeys in the rainforest. And this is basically induction. But there's a key problem here, right? And the problem is that you can be wrong. The problem is that there's always room for error. It's always possible that you may come across another monkey. The 200,001st observation, the monkey will be green. It will have green fur, right? It's possible that it'll have blue fur or brown fur or yellow fur. It's always possible that there's a future observation which will make you or lead you to having to change your conclusion, your previous conclusion. So this is the problem of induction. If this is the case, it's impossible to have certainty. How can you be certain of your conclusions? Because they're not based on the entire set of data. It was based on this limited batch of data that you have, right? So it's possible in the future, you may have future observations which allow you or lead you to changing your conclusions. And if this is the case, then science can't give you 100% truth. It can come close to it. It can maybe give you 98% or 99%, but it's always possible that your entire theory, your entire conclusion will be changed with future data observations. And this is the problem with induction. You can never be certain. Let's take another example. Take water. We know water boils at 100 degrees Celsius. Have we observed every single possible time water boils? Or have we seen every single time water will boil till eternity? No. Right? So it's always possible, although there's a minute chance, maybe even a very fragmentary small chance that the next time you boil water, it will boil at 102 or 104 degrees, but it's always possible. So you can't conclude conclusively. You can't say 100%, it's absolutely true without a shadow of a doubt that water boils at 100%, 100 degrees Celsius, and that's it. This is fact. No, you can't say that. Science doesn't deal with absolutes. Science deals with possibilities. Maybe it's this way. We're close to thinking it's this way. You can call it a truth. Scientists call this a truth. Scientists can say, well, this is a scientific truth, but we have to remember and keep in mind that a scientific truth doesn't equal actual absolute truth. Okay, the term is used in two different ways when it comes to science. So this being the case, brothers and sisters, just based on this one thing, the problem of induction, and there's many problems within the scientific method, just this one, we can see science doesn't give you absolute truth. So the key thing here to understand, brothers and sisters, is that science is revisable, and this is a key term, right? And in future episodes, we're going to look at a very interesting case study, which is to do with evolution and the Darwinian mechanism, which is very interesting. But the point here is we need to remember that science is revisable. And we're going to see how this reality of science translates over to the theory of evolution and the Darwinian mechanism in future episodes. But understand this, and I'm going to keep repeating this, science is revisable. It's not absolute truth as we've been led to believe. So we need to make sure we understand this. The textbooks may say one thing, but when you really study the philosophy of science, you realize this reality. The next thing I want to touch upon is conclusions, right? Now, here's something very interesting. Say you've collected a good batch of data, right? You've been studying something and you've collected a good, solid set of data. Let's say, I don't know, birds flying over Scotland, right? So you collect your data, you take it back, you sit there, you study it, you look into it, you understand it, and then based on your data as a scientist, what you do is you infer a conclusion. You make a conclusion based on the data, right? Now, here's another interesting problem. Another scientist may come along, study the same data, and come to a totally different conclusion to you. This is something that happens all the time. You can have the same data, and different scientists come to different conclusions based on the same very data. Here's an analogy, here's a little thought experiment you could do to put things into perspective. Imagine a graph, right? Now on this graph you have dots, right? You can have your scatter graph, you have little dots on this graph. Now one person may come and get a pen and he has to join these dots or show the best line that crosses through these dots. He may come and he may join these dots by drawing a line from the corner of the graph all the way through, and he tries to fit it the best he can through all the points to come as close as he can to all the points with this line. That's one individual. Another individual may come with a pen and he may draw a squiggly line which goes through every single point. Okay? A third individual may come and he say, you know what? It has to be circles. So he comes and he draws circles around every single point, making sure he goes through every single point as he's drawing circles. Now what we can see here is that there's the same graph, it's the same dots on the graph, but three different people have drawn three different lines in trying to join these dots together, right? So this is what happens. You have the same data, but different scientists may observe this data, see this data, and come to totally different conclusions. This is another problem. And if this is the case, then how do we know that the conclusion we're making, that we're inferring based on this data, is the correct conclusion? We can't be certain again. And this is the thing. So again, to emphasize the point, science, this is why science is revisable. It can change. It's not absolute. It's not set in stone. It's not the gospel truth. It can change. Let's look at another problem. Here's another interesting problem. Scientists will say generally when you present these things to them, or atheists would say, well, you know what, put all of these things aside. Science works. It works. It gives us results, right? We have medicine which works. We have all of these amazing developments and technologies which have come about by science. So it works. It doesn't matter what you're saying. Now in a way that's true. But here's what's interesting. Just because it works, it doesn't mean it's true. I'm going to explain this in a second. But again, I want to emphasize something here. As Muslims, we're not against science. We love the scientific method. All we're trying to do is put the scientific method in its place where it deserves to be and not make it out to be something excessive. So what do I mean by when I say just because it works, it doesn't mean it's true? Now we know that there's been many scientific theories which have led to the discovery of certain things which are true, but those theories themselves later on have been revised or changed or gotten rid of completely, right? Take the theory of phlogiston. Phlogiston led to the discovery of nitrogen in 1772, right? And we know nitrogen is real, it's there. But the theory of phlogiston itself was disproved. They got rid of it, right? So this shows us that certain theories or ideas or concepts within science currently may lead to the discovery of certain things which are true, right? But it doesn't mean that that very thing is true itself. And this is another perplexing mystery about science. How does this work? Allah knows best, but the point is that this does happen. So you can have something which leads to a truth, but itself is disproven later on. This is another very interesting problem of the scientific method. So brothers and sisters, in conclusion, Science is revisable, right? It can change. It can always change. It doesn't give you absolute truth. It doesn't give you absolute facts. It doesn't deal with that. And as we've seen, number one, first and foremost, the problem of induction, which is you always have a limited set of data. Based on this data, you make a conclusion, but that conclusion can change because it's always possible you can have more data that comes up in the future or future observations which contradict that data. Number two, we looked at different theories, the way different theories can be drawn from the same set of data. Different conclusions can be made from the same set of data. That's something interesting as well. The graph we talked about, where the same crosses and dots on the graph can be lined through in many different ways. Also, we looked at the reality that, someone may say, well, science gives us results. It works. We have medicine. We have these amazing things. Therefore, we don't need to question these things. Fine. But the point is, as we've seen with the theory of phlogiston, you can have something, a theory or a reality, which leads to truth, but then later on itself is disproven, right? So this is another issue. Again, you can't claim truth. So in conclusion, science is a beautiful method. Yes, it works. We love it as Muslims. We want to use it as Muslims, progress in it, but we realize it's limited. Science is revisable. It can change. And this is the reality of the scientific method. So hopefully, brothers and sisters, this has been beneficial. Jazakallah khair for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.